everybody. In this video, we're going to talk about the compound interest formula and where it comes from. So take 3 deep breaths and let's make this math easy. Okay, so let's say we were going to invest $4,000 at an annual rate of 5% for 3 years. So if we wanted to figure out the amount of money that we would have at the end of the 3 years, it depends on whether we're using simple interest or compound interest. Because with simple interest, you're only earning interest on the money that you invested, but with compound interest, you would earn that interest as well as interest on the interest that you'd already earned. So for example, with simple interest, we would just do 4,000 times 1.15 because we would be earning 15% interest total over the 3 years. And then the 1 is because we would also have 100% of our initial investment. And if we multiply those two numbers together, we would find out that we would have $4,600 at the end of 3 years if we invested it with simple interest. Now, if we did it with compound interest, it would be calculated a little bit differently because at the end of the first year, you would have $4,000 times 100% plus 5% interest, which would equal $4,200. So that's the amount of money we would have in the account at the end of the first year. And then at the end of the second year, we would take that amount that we had in year 1 and we would multiply that by 105%. Again, that's 100% because we keep all of the money that's in the account, and then we also have an additional 5% for the interest. And when we multiply those together, we get 4,410. And then on year 3, we would have 4,410 multiplied by 1.05, and that would give us a total amount of $4,630.50. And if you look at this, you'll notice that we have more money with compound interest than we do with simple interest. And that's because we're earning interest on the interest each year. And there's an easier way to calculate this so you don't have to write out all of the years. Because essentially what we did was we took our initial investment of $4,000 and then we multiplied by 105% to figure out how much we would have at the end of the first year. Then we took that amount and multiplied by 105% to get the amount after the second year. And then we multiplied by 105% again to get our final amount of $4,630.50. And if you look at this, you'll notice that we're basically repeatedly multiplying by the 105%. So a shorter way to calculate this would be to do 4,000 times 105% raised to the third power because we multiplied by 105% 3 times to get the amount by the end of year 3. So that amount, if you were to calculate that in your calculator, would give you the exact same answer, and it's much faster than having to write out all of the steps like this. Now, typically, when we do compound interest, we're not compounding it yearly. We'll be compounding it monthly or quarterly or even daily. And you'll also be doing a project where we'll talk about how you can actually compound it an infinite number of times. But let's talk about how we would handle it if we were compounding interest, say, for example, monthly. So if we were investing $3,000 at an annual rate of 6%, which was compounded monthly for 7 years, well, basically what that means is this 6% annual rate for the entire year needs to be divided by 12 to find the monthly interest rate, and then you'll compound that interest every month. So the monthly interest rate, if we were to calculate this, would be 6% divided by 12, which equals 0.005. So essentially, it's a 0.5%. And that interest rate is going to be compounded every single month. So if we were to write out how we would calculate this, we would do 3,000, and after the first month, we would multiply by 1.005. Then after the second month, we'd multiply by 1.005 again, all the way until the very, very last month. And after you multiplied all of those together, that would give you the amount that you would have at the end of 7 years. So the question is how often is this multiplied? And if we were doing this every month for 7 years, we could rewrite this as 3,000 times 1.005 raised to 7 times 12. Because if we do it for 7 years and there's 12 months in a year, then 7 times 12 will tell us how many months we compounded this interest for. So if we calculate that out, we're going to get 3,000 times 1.005 raised to the 84, because 7 times 12 is 84. And then to do order of operations, we'll do our exponent. So 1.005 raised to the 84 is 1.520396. And you want to make sure you always keep at least 6 decimal places so that you don't end up with a rounding error in your final answer. And when we multiply 3,000 times that decimal, we end up with a total amount of $4,561.11. And so this is the amount of money we would end up with at the end of the 7 years if this interest was compounded monthly. And so this is the general compound interest formula, and this formula is basically generalizing what we did on the last slide. So in this formula, we have several different variables. We have A, which represents the total amount at the end, just like with simple interest. P is the initial amount that you invest or borrow at the beginning. R is the interest rate. And K is a new variable that represents the number of times we're compounding the interest per year. So if we're compounding the interest annually, then that would mean K equals 1. If it's semi-annually, K would equal 2. Quarterly, K would equal 4. Monthly, K would equal 12. And daily, K would equal 365. And sometimes in your quizzes, they'll say to use the banker's rule, where you're going to actually use K equals 360. And that's just an approximation that bankers sometimes use because it's easier to divide by 360 than 365. So K represents the number of compounds per year, and T represents the number of years. So if we look at this formula, we can see that this part of the formula right here is basically taking the annual interest rate and splitting it up into however many compounds there are in a year. So if you were doing like a 5% interest rate every month, then you would divide that 5% into 12 groups to figure out what your monthly interest rate would be. If it was daily, you divide by 360 or 365, depending on whether you were using the banker's rule. So that's what that part of that equation says. And then you add 1 because you also, in addition to your interest percentage, you also keep 100% of your initial amount. And then this exponent, T times K, basically tells you how many compounds you're doing total, because K is the number of compounds per year and T is the number of years. And so basically this part of the formula represents multiplying by your interest rate, however many times you compound it. And then the thing that you're multiplying by this interest rate is the initial amount you invest. And so that's where this formula comes from. And in the future videos, I'm going to show you how to calculate for P and how to calculate for A. And you won't have to calculate for R or T or K because those would require logarithms and roots and things like that. And we're not going to get that complicated in this class. But you will be solving for the total amount at the end as well as the initial amount that you've invested. So I hope this video was helpful and I hope you guys have a good day.